All right, so this lecture is about the Pythagorean Theorem, which relates the sides of a right triangle, and a right triangle has a 90-degree angle in it, so that's marked by the square. The legs are the sides that make up the right angle, so they labeled these A and B, and then the hypotenuse is the opposite side of the 90, which would be C. So the Pythagorean Theorem basically says that the sum of the square of the legs, so if I add up a squared plus b squared, that's going to equal the hypotenuse squared, which is c squared. So the sum of the square of the legs equals the square of the hypotenuse. So every right triangle has this relationship. So in these examples, these are both right triangles. And let's say that you are given the length over here as 3 inches, and maybe this length is 4 inches, and they want you to find the other side. So when we look at a right triangle, we need to determine which side is missing, and this is opposite the right angle, so we're actually missing C, which is the hypotenuse. So we can use the Pythagorean theorem that says if I take the square, the sum of the square of the legs, so if I take 3 squared, add it to 4 squared, that's going to equal the square of the hypotenuse, which is C squared. So just evaluating 9 plus 16 equals c squared, 25 equals c squared. So here we can use the square root property and take the square root of both sides, and we get plus or minus 5 equals c. And we only need the positive value for c, so we only need the positive value since c is a length. So this is dealing with the lengths, the sides, so therefore c would be equal to 5, positive 5, and then the units are inches in this case. So this one came out to be exact, but sometimes in a right triangle, maybe you're given this side, which is 5 feet, maybe, and maybe you're given this side, which is 10 feet, and now we want to find the other side. Well, in this problem, we notice that one of the legs is missing, so maybe I'll call this side B, and the Pythagorean theorem says if I take the sum of the square of the legs, so if I take one of the legs is 5 and add it to b squared, that should equal then hypotenuse, which is the 10 feet, be 10 squared. So now I want to solve for b squared, so I get 25 plus b squared equals 100. Subtracting 25 from both sides, we're getting b squared equals 75. So if we take the square root and just look at the positive, we know that b must equal the square root of 75. So the square root of 75 is not a perfect square. So we can simplify this by looking for perfect square factors. So I can split this into the square root of 25 times the square root of 3. So it looks like we get b equals 5 times the square root of 3. So this would be the exact answer in feet in this case. If we approximate b, we could plug this in our calculator and get approximately 8.66 feet. So in applications dealing with the Pythagorean theorem, we just have to notice a right triangle in the application. So this is talking about a 37-foot ladder that's 9 feet from the wall, and it wants to know will the top reach a window ledge that's 35 feet above ground. So in our problem here, we actually see the right triangle that we're looking at here. I'll just outline it. So the height that we're looking for with the ground forms a right angle. The ladder then would represent the hypotenuse. So the legs of the right triangle are h, which is the height, and 9, which is the base, and the hypotenuse would be the 37 feet. So if we plug this into our quadratic formula, I know that h squared plus the base squared, 9 squared, would have to equal 37 squared. So again, we want to solve for h squared, so we're just evaluating. 9 squared is 81, 37 squared is 1,369. Subtracting 81 from both sides to solve for h squared, we get h squared equals 1,288. And taking the square root of both sides, we get h equals the square root of 1,288. Now, if we approximate this, if we put this in our calculator, the square root of 1,288 is approximately 35.9. And what we needed to do was just basically compare it to the window ledge that's 35 feet above ground. Well, 35.9 is greater than 35, so therefore the ladder will reach the window ledge. All right, so the next application is dealing with telephone cable. If we look at the illustration, they give us some measurements, and they want us to find the distance between A and D, which is the blue dotted line. So what we need to do is recognize a right triangle in this application. So if you look at this, I'm looking for this diagonal here, but if I extend this side down and use the base here, this would actually be a right triangle. So I have a right triangle that looks like this. My dotted line going here. So again, here's my right triangle. The base is the same as the distance here, so this would be 52 yards. And if we notice the side on here, from D to here is 60 feet, so 60 yards, excuse me, and the rest of the distance would be the same as 105 yards. So the total distance on that side of the triangle would be 165 yards. So I want to try and find basically the hypotenuse, C. If we plug this into our quadratic formula, I mean not quadratic formula, Pythagorean theorem, I know that the sum of the square, or the hypotenuse squared, and I'll just label this with C, so C squared is equal to the square. All right, so Pythagorean theorem gives me then C squared equaling 52 squared plus 165 squared. So again, just evaluating and solving, we get C squared. 52 squared is 2,704 plus 165 squared is 27,225. Adding those together, we get 29,929. So C should equal the square root of this 29,929. And actually, this square root of 29,929 comes out to be exactly 173. So therefore, we need 173 yards of table.